Hi, in this lesson, we will be learning about the rate of diffusion of gases. These are the success criteria that will be covered in this lesson. Do take a few moments to read through the success criteria before you start this lesson. The first question we ask ourselves is, do all gases diffuse at the same rate? Now, asking this question is equivalent to asking, do all human beings run at the same pace? And the answer is a definite no. So what sets the gases apart that affect the rate of diffusion? Now for humans, right, we all run at different pace. It is because of our own physical ability, of our fitness, and that might have got to do with our weight, our height, and etc. For gases, this has got to do with their relative molecular mass, MR in short. So relative molecular mass is like the weight of the gas, meaning it tells us how heavy the gas particle is. So how do we calculate it? Very simple. Just go to your periodic table and you will see the symbol of the element that is accompanied by two numbers, one above and one below. Now the top number is the relative atomic mass of that element. So, for example, one oxygen atom will be 16, that will be the mass. And for one nitrogen, the relative atomic mass will be 14. For carbon, it will be 12, and for bromine, 18. So we always take the top numbers for reference. So to calculate it for a gas, we first need to have the formula for the gas. Example, oxygen gas. We know the formula is O2, 2 oxygen atoms. Hence, we just need to take 16 and multiply it with 2, so we will get 32. And we do the same for carbon dioxide gas as well. A carbon atom, so 12, plus 2 oxygen atoms, and hence overall we have 44. Now, the gas with the higher relative molecular mass will be the heavier gas. So in this case, do you think oxygen or carbon dioxide is the heavier gas? Correct. Carbon dioxide is the heavier gas. It has a higher relative molecular mass. Now, let's watch a video to better enhance this understanding of relative molecular mass. So in this video, we will be comparing the rate of diffusion of bromine with the rate of diffusion of nitrogen dioxide. Let's see which gas will diffuse faster.
This simple setup can be used to compare the rate at which different gases diffuse into air. Nitrogen dioxide gas on the left is similar in colour to bromine on the right, but bromine molecules are much heavier. The lighter nitrogen dioxide diffuses more quickly.
Right. So, as in the video, they actually say that bromine gas is the heavier gas. So, from what we have learned earlier, how can we validate this conclusion? Correct. We will need to calculate the relative molecular mass of both the gases. So, let's do it for nitrogen dioxide. NO2. So 14 plus 2 oxygen, so 16 and 16 will give us 46 for nitrogen dioxide. The relative molecular mass of bromine will be simply 2 times 80 or 80 plus 80, and we'll get 160. So which one will diffuse faster? We have already mentioned earlier that the gas that is lighter will diffuse faster. Okay, so from the MR we can see that nitrogen dioxide is the lighter gas, hence it will diffuse faster. And since it diffuses faster, the total time taken will be less than half an hour for it to reach equilibrium in concentration. So, in conclusion, we can conclude bromine diffuses slower than nitrogen dioxide because bromine particles have a greater relative molecular mass than that of nitrogen dioxide particles. Just think of it as the heavier gas particle will diffuse at a slower rate compared to the lighter gas particle. Right, now if you refer to notes page 2, you will have this practice section. Can you please complete this exercise on your own now? You may pause the video as you try to work out the calculation. But I will proceed on with revealing the answer, so please pause the video before you look at the answer. Is this the answer that you have got? Now, when you're calculating MR, you need to show the breakdown in calculation. Do not just write the final answer for me. I need to see the breakdown in calculation. You can either write 1 plus 1 for hydrogen, or you can give me a 2 times 1, because there are 2 of hydrogen atoms, and the mass of 1 hydrogen is 1. So 2 times 1 will work as well. For oxygen, if you give me 2 times 16, it is fine as well, so long as you show the breakdown in calculation. So as mentioned earlier, if you are lighter, then you will diffuse faster. So hydrogen will diffuse at the fastest rate, followed by oxygen. And last but not least, carbon dioxide, because it has the highest relative molecular mass, hence it is the heaviest, and it will diffuse the slowest. Now, by now, you should have completed these 2 success criteria. You are able to calculate the relative molecular mass of a given substance, and you should be able to describe that as the relative molecular mass of a gas increases, the rate of diffusion will decrease. That's all we have for this lesson. Thank you.